So our next chapter is nitric acid. Again, here we will learn about its laboratory preparation, some of its important properties and only a few of its reactions. So for preparation of nitric acid, we will use the same type of procedure that we used for hydrogen chloride gas. We used sulfuric acid and we used a salt. Over here also we will use sulfuric acid and we will use sodium or potassium nitrate. So KNO3 plus H2SO4, the reaction is exactly same. If the temperature is lower than 200 degrees Celsius, we will get KHSO4 and HNO3. But if the temperature is above 200 degrees Celsius, it will form K2SO4 and HNO3. We will learn in the next page. Similarly, in place of KNO3, we can also use NaNO3, sodium nitrate. It is upon us. So how it is collected, as you can see, in this case also we have a round bottom flask which is tilted a little bit, and from top a water tap has been placed so that the nitric acid can be cooled down. We will learn about it. The vapors of nitric acid are condensed to a light yellow liquid by chilling the receiver with running cold water. So this is the necessity of the tap. So the nitric acid which is formed is in the form of vapor that has to be converted into the liquid form by cooling it. So cooling is done by using this tap. So the pure acid is actually colorless, but the acid which is obtained in the laboratory has a slightly yellowish color. It is because a few molecules of HNO3, it starts thermal decomposition. It breaks up into water, nitrogen dioxide and oxygen. So because of this nitrogen dioxide, we get this yellowish color, but it can be removed. If we add a little more water in the acid, then this yellowish color will be removed. If dry air or carbon dioxide is bubbled through the yellow acid, the latter turns colorless because it drives out the NO2 from warm acid, which is further oxidized to nitric acid. So either we can either we can dilute it with water. Also, if we allow dry air without any water vapor or carbon dioxide into the yellowish nitric acid, even then the yellowish color will get removed. The nitrogen dioxide will get removed. So these two processes can be done. What are the precautions which must be followed during this procedure? All the apparatus should be made up of glass. None of the apparatus should have cork or rubber in it because nitric acid vapors can react with that. Concentrated HCl is not used in this case. H2SO4 is used because H2SO4 is non-volatile but HCl is volatile. Also, if HCl is used, since HCl is volatile in nature, so the nitric acid vapors which will be formed in the round bottom flask, that might also contain a few vapors of HCl, which is not desirable. So we use sulfuric acid. Also, again, why do we use KNO3 or NaNO3? It is cheap, just like the previous two chapters. Also, the temperature should not exceed 200 degrees Celsius because we know K2SO4 or Na2SO4 will be formed, which is very difficult to remove. So at higher temperature the glass apparatus may break, fuel will be wasted, and the nitric acid can also decompose. The nitric acid will start breaking down, which is not required, right? Next is a harmful effect of nitric acid. Although nitric acid is non-poisonous as such, but if it falls on the skin, it can cause blisters. So the skin becomes yellowish in color when nitric acid falls on the skin. This is because it reacts with the protein on our skin and it will produce xanthoprotic acid. Very important. This is the only thing you have to remember from its psychological action. Xanthoprotic acid is formed, which gives the skin a yellow color. Now, since the first chapter I told you that nitric acid cannot be used for the normal reactions of an acid because nitric acid is a very strong oxidizing agent. So we are going to see 4 such reactions of nitric acid as an oxidizing agent. So we will see the reaction of nitric acid with carbon, with sulfur, with copper in case of dilute nitric acid and in case of concentrated nitric acid. Let's see. Carbon, when reacts with nitric acid, we will get carbon dioxide, we will get water, and we will get nitrogen dioxide. Similarly, if sulfur reacts with nitric acid, we are getting H2SO4, we are getting sulfuric acid. This is different. And we are getting water and we are getting nitrogen dioxide. We are not getting sulfur dioxide, we are getting sulfuric acid. Similarly, when copper reacts with cold and dilute nitric acid, we will get copper nitrate, we will get water, and we will get nitrogen monoxide, NO. But in case if we use concentrated nitric acid or we use hot dilute acid, we will get copper nitrate, we will get water, but we will not get nitrogen monoxide, we will get nitrogen dioxide. This is the only difference. So these 4 reactions you have to remember very nicely because these are the only reactions you have to learn in this chapter for nitric acid. Next we are going to learn about the Ostwald's process. This is the process by which nitric acid is manufactured in a bulk amount, in a large amount. So there are 3 steps for this. You just have to remember the reaction, the conditions which are required for the reaction, and certain important things. So the first step is the catalytic oxidation of ammonia. You have learned it in the previous video how ammonia is oxidized in the presence of a catalyst. So this process is done in a chamber called catalytic chamber. So let's see the reaction. NH3 reacts with oxygen in the presence of platinum and at 800 degrees Celsius to produce nitrogen monoxide, water and lots of heat. This reaction is exothermic. We have learned in the previous video also. Now whatever is formed, this is passed to the next chamber where oxidation of nitric oxide will happen. This nitrogen monoxide that will get oxidized. So NO is treated with oxygen at a temperature of 50 degrees Celsius to form nitrogen dioxide. This temperature is essential. After this, what happens? This nitrogen dioxide will be mixed with water in the presence of oxygen and we will get nitric acid. This is done in the chamber called absorption tower. The absorption tower is actually a tower made up of quartz. We will learn why quartz is used. So the reaction is nitrogen dioxide plus water plus oxygen. It will give you HNO3, nitric acid. So this nitric acid is concentrated and then this concentrated acid is used in the laboratories. Why do we use quartz? Because quartz is acid resistant. Even if acid falls on quartz, nothing will happen. Also the dissolution of nitrogen dioxide with water happens very uniformly in the presence of quartz. So this nitric acid which is used in the laboratory is only 68% concentrated, but if it is concentrated up to 98%, that type of nitric acid is known as fuming nitric acid. So this is all that you have to study in this chapter. So go through the reactions and practice it in your copy. So this is the decomposition of nitrates in the presence of heat. It is also known as thermal decomposition. So in case of sodium and potassium, it is producing one type of product. In case of calcium, zinc, lead and copper, it is producing one type of product. In case of silver and mercury, it is producing one type of product. And for NH4NO3, ammonium nitrate, it is completely different. So that's why I have used different colored sketch pens to mention their differences. So when sodium nitrate and potassium nitrate are heated, we will get nitrite, so NaNO2 or KNO2, and along with that oxygen gas will be released. When we heat calcium nitrate or zinc nitrate or the other two nitrates which I have written, we will get calcium oxide, we are getting the metal oxide, we are getting nitrogen dioxide gas NO2 and we are getting oxygen again. So oxygen is common to all the first 3 types of reactions. Similarly, if we heat lead nitrate, we are getting lead oxide, we are getting nitrogen dioxide and we are getting oxygen. Now if we heat silver nitrate, we are getting silver. We are not getting oxide of silver. We are just getting silver. We are getting nitrogen dioxide and we are getting oxygen. Similarly, if we heat the nitrate of mercury, we are getting mercury. We are getting nitrogen dioxide and we are getting oxygen. Now in case of NH4NO3, when it is heated, we will get nitrous oxide, N2O. It is also known as laughing gas. And we are getting water, completely different. So this is the most unique one. The others are more or less interrelated. So you have to remember this, the thermal decomposition of only these few nitrates.